What is programming? Today, we're diving into the fascinating world of programming. Let's begin by defining what programming is. Programming, simply put, is the art and science of creating sets of instructions for computers to follow. These instructions, known as code, dictate the behavior and actions of computers, allowing them to perform tasks ranging from simple calculations to complex operations. Now, why is programming so important in today's world? Well, let's think about it. Programming is the backbone of virtually all modern technology. From the applications on your smartphone to the systems running the scenes of your favorite websites, programming is everywhere. One of the key reasons programming is so crucial is its ability to automate tasks. By writing code to handle repetitive or laborious tasks, we can streamline processes, making them more efficient and scalable. Moreover, programming fuels innovation. It empowers individuals and organizations to create new software, tools, and technologies that push the boundaries of what's possible. In essence, programming is the driving force behind progress in the digital age. And let's not forget about the value of programming skills in today's job market. In a world increasingly reliant on technology, individuals with programming know-how are in high demand, with opportunities spanning a wide range of industries. So, what can you expect from today's presentation? We're embarking on a journey to unravel the intricacies of programming, starting from beginnings to its profound impact on society today. Throughout this presentation, we'll delve into various aspects of programming. We'll explore its history, its evolution over time, and the different paradigms that shape the way we write code. But we won't stop there. We'll also take a closer look at real-world applications of programming, from building software to solving complex problems in fields like artificial intelligence and data science. By the end of our time together, my aim is for you to walk away with a deeper understanding of what programming is all about and why it's so vital in today's interconnected world. So, without further ado, let's dive into the exciting world of programming. Now that we've touched on the importance of programming, let's delve deeper into what it actually entails. At its core, programming is about creating a sequence of instructions that enable a computer to perform specific tasks or solve problems. These instructions, known as code, serve as the bridge between human intentions and machine actions. Think of it this way: programming is like giving directions to a computer. You're telling it what to do, step by step, in a language it understands. Several key components make up the world of programming. Code. This is the heart of programming. It's the set of instructions written by a programmer using a programming language. Compiler or interpreter. Once the code is written, it needs to be translated into machine-readable instructions that the computer can understand and execute. This is where compilers or interpreters come into play. They take the human-readable code and convert it into a format that the computer can process. Execution environment. This encompasses the platform or system where the code runs. It includes the hardware, operating system, and any software dependencies needed to execute the code effectively. When you boil it down, programming is essentially the art of translating human intentions into machine-executable actions. It's about empowering computers to perform a wide range of functions efficiently and accurately, from simple calculations to complex algorithms. So, the next time you write a piece of code, remember that you're not just typing lines on a screen. You're crafting a set of instructions that have the power to shape the digital world around us. Now that we've explored what programming is, you might be wondering why it's worth investing your time and effort into learning it. Let's take a closer look. Firstly, programming skills open doors to a vast array of career opportunities. In today's digital age, where technology permeates every aspect of our lives, the demand for skilled programmers is higher than ever before. Whether you're interested in software development, data analysis, web design, or any other tech-related field, proficiency in programming can pave the way for lucrative job prospects and career advancement. With the rise of industries like artificial intelligence, blockchain, and cybersecurity, the opportunities for programmers are virtually limitless. So, if you're looking to future-proof your career, learning programming is an excellent place to start. Programming is not just about writing code, it's also about solving problems. Through the process of coding, individuals develop critical thinking and analytical skills by breaking down complex problems into smaller, more manageable tasks. This fosters a mindset of creativity and innovation, as programmers constantly seek out novel solutions to real-world challenges. Whether you're designing a new software application or optimizing an existing system, programming encourages you to think outside the box and explore unconventional approaches to problem solving. One of the most exciting aspects of programming is its capacity to unleash creativity and drive innovation. By mastering programming languages and tools, individuals gain the ability to create new software applications, tools, and technologies that address societal needs and improve efficiency. Whether it's building a mobile app to streamline everyday tasks or developing a groundbreaking algorithm for predictive analytics, programming is a platform for experimentation and exploration. It empowers individuals to turn their ideas into reality and make a tangible impact on the world around them. Lastly, learning programming enhances your understanding of how technology works. From the internet and mobile devices to artificial intelligence and machine learning, programming touches virtually every aspect of modern technology. By diving into the world of programming, you'll gain insights into the inner workings of these technologies, allowing you to be more informed users and better equipped to adapt to future advancements. So, whether you're passionate about pursuing a career in tech or simply curious about how technology shapes our world, learning programming is a valuable skill that can open doors to endless possibilities. Now that we understand the importance of programming and its relevance in today's world, let's take a step back and explore its fascinating history. Programming traces its roots back to the early days of computing, where visionaries such as Ada Lovelace and Charles Babbage laid the foundation for what would become modern programming. Ada Lovelace, often regarded as the world's first computer programmer, worked with Babbage on his analytical engine, envisioning a future where machines could be programmed to perform various tasks. As computing technology advanced, so too did the languages used to program it. The evolution of programming languages from machine code and assembly language, which were cumbersome and difficult for humans to understand, to higher-level languages designed for human readability and ease of use. Throughout history, there have been significant milestones in the world of programming. One such landmark achievement was the development of the ENIAC, one of the first electronic computers, in the 1940s. This massive machine, weighing over 27 tons, marked a significant leap forward in computing technology and laid the groundwork for future innovations. Additionally, the mid-20th century saw the creation of several programming languages that revolutionized the field. Languages like Fortran, COBOL, and ALGOL paved the way for more efficient and accessible programming, making it easier for developers to write complex code and build sophisticated applications. Each milestone in programming history has had a profound impact on the advancement of technology. From the invention of electronic computers to the development of high-level programming languages, each innovation has expanded the possibilities of what computers can achieve. Today, we stand on the shoulders of giants, benefiting from the groundbreaking work of those who came before us. As we continue to push the boundaries of technology, it's essential to remember and appreciate the rich history of programming that has brought us to where we are today. Now that we have a grasp of programming's history, let's explore the different types of programming languages that have emerged over time. Low-level languages are closely tied to the hardware of a computer and provide minimal abstraction from its architecture. These languages interact directly with the computer's hardware and are typically used for tasks where precise control over hardware resources is required. Examples of low-level languages include machine code and assembly language. In contrast to low-level languages, high-level languages are designed to be more user-friendly and abstracted from the hardware. These languages are easier to read, write, and maintain, making them ideal for developing complex applications. Examples of high-level languages include Python, Java, C++, and C#. Scripting languages are used primarily for automating tasks, often in the context of web development, system administration, and data processing. These languages are typically interpreted rather than compiled, allowing for rapid development and prototyping. Examples of scripting languages include JavaScript, Ruby, and Python, which is also used as a high-level language. Finally, we have specialized languages, which are tailored for specific domains or tasks. These languages provide specialized features and syntax optimized for their respective purposes, making them highly efficient for certain applications. Examples include SQL for database management, R for statistical analysis, and HTML/CSS for markup and web design. Each type of programming language has its strengths and weaknesses, and the choice of language often depends on the specific requirements of a project. By understanding the characteristics of different languages, programmers can select the most suitable tool for the job at hand, ultimately leading to more efficient and effective software development. Now that we've covered the different types of programming languages, let's explore the various programming paradigms that shape the way we write code. Procedural programming focuses on the sequence of steps and procedures to solve a problem. Programs are organized into procedures or functions that perform specific tasks, making it easier to break down complex problems into manageable pieces. Languages like C and Pascal are examples of procedural programming languages. Object-oriented programming, or OOP, organizes code into objects that encapsulate data and behavior. This paradigm emphasizes concepts like inheritance, polymorphism, and encapsulation, allowing for modular and reusable code. OOP is widely used in languages such as Java, C++, and Python, making it a fundamental paradigm in modern software development. Functional programming treats computation as the evaluation of mathematical functions. It emphasizes immutability, higher-order functions, and declarative programming, where programs are written to describe what should be done rather than how it should be done. Languages like Haskell, Lisp, and Clojure follow the functional programming paradigm, offering elegant solutions to complex problems. Logic programming is a declarative programming paradigm where programs are written as sets of logical rules. One notable language used for logic programming is Prolog, which allows programmers to express relationships and constraints using logical predicates. Logic programming is particularly well suited for tasks involving symbolic reasoning and rule-based systems. Each programming paradigm offers unique approaches to problem solving and is suited to different types of applications and programming tasks. By understanding these paradigms, programmers can choose the most appropriate approach for their projects, leading to more efficient and maintainable code. Now that we've covered the different paradigms, let's delve into the fundamental building blocks of programming. Variables are used to store data values within a program. These values can be manipulated and accessed throughout the execution of the program. Data types define the nature of the data that can be stored in variables. Common data types include integers, floats, strings, and booleans, each representing different types of values such as whole numbers, decimal numbers, text, and true/false values. Control structures govern the flow of execution within a program, allowing program to control how code is executed based on certain conditions. Loops, such as for loops and while loops, enable repetitive execution of code blocks, while conditionals, such as if statements and switch statements, allow for decision-making based on specific conditions. Functions are blocks of reusable code that perform a specific task. They encapsulate a set of instructions and can be called from other parts of the program to perform their defined task. Procedures, also known as methods or subroutines, are similar to functions but may not return a value. They help modularize code by breaking it into smaller, more manageable chunks, promoting code reusability and maintainability. By understanding these basic concepts of programming, you'll be well equipped to start writing your code and exploring the endless possibilities of software development. Whether you're creating a simple script or building a complex application, mastering these fundamentals is essential for becoming a proficient programmer. Now, let's explore the concept of algorithms, which are essential tools in the arsenal of any programmer. An algorithm is a step-by-step procedure or set of rules designed to solve a specific problem or perform a particular task. In the world of programming, algorithms serve as systematic approaches to problem solving, guiding programmers in developing efficient and effective solutions. Algorithms are the backbone of programming, providing a structured framework for tackling a wide range of problems, from sorting and searching to graph traversal and optimization. Let's take a look at some common examples of algorithms. Sorting algorithms. These algorithms arrange elements in a specific order, such as ascending or descending. Examples include bubble sort, merge sort, and quicksort. Searching algorithms. Searching algorithms are used to locate a target value within a collection of data. Examples include linear search and binary search. Graph traversal algorithms. These algorithms explore and traverse graphs to find paths or connections between nodes. Examples include breadth-first search, BFS, and depth-first search, DFS. Effective algorithms exhibit several key characteristics. The algorithm should produce the correct output for all valid inputs, ensuring accuracy and reliability. An efficient algorithm executes in a reasonable amount of time and uses minimal resources, making it scalable and practical for real-world applications. The algorithm should be easy to understand and maintain by other programmers, promoting collaboration and code maintainability. Understanding algorithms is crucial for developing efficient and scalable solutions to programming problems. By mastering the principles of algorithm design and analysis, programmers can tackle complex challenges with confidence and precision, ultimately leading to better software solutions and improved user experiences. Now, let's explore the art of problem solving, a cornerstone skill for any programmer. Effective problem solving often involves employing a combination of strategies. Decomposition. Break down a complex problem into smaller, more manageable sub-problems. This approach simplifies the problem-solving process by tackling each component individually. Pattern recognition. Identify common patterns or structures within the problem to devise solutions. Recognizing recurring themes can lead to more efficient problem-solving strategies. Abstraction. Focus on the essential details of a problem while ignoring irrelevant information. Abstraction allows programmers to distill complex problems into simpler, more manageable concepts. Algorithm design. Develop step-by-step procedures to solve each sub-problem efficiently. Algorithms provide structured frameworks for solving specific tasks or problems. There are several techniques for breaking down problems into smaller, more manageable steps. Divide and conquer. Divide a problem into smaller sub-problems, solve each independently, and combine the results. This approach is particularly effective for tackling large, complex problems. Top-down design. Start with the overall problem and progressively break it down into smaller components. This hierarchical approach allows programmers to focus on high-level concepts before delving into the details. Bottom-up approach. Build solutions for individual components and gradually integrate them into a complete solution. This approach emphasizes incremental progress and iterative refinement. Once a problem is decomposed into smaller steps, algorithms can be applied to solve each step systematically. Choosing appropriate algorithms involves considering factors such as efficiency, complexity, and suitability for the problem domain. Problem-solving skills are essential for programmers to tackle diverse challenges and develop effective solutions in various domains. By mastering problem-solving strategies and algorithmic techniques, programmers can overcome obstacles and achieve their programming goals with confidence. Let's delve into the tools and environments that empower programmers to bring their ideas to life. Integrated Development Environments, or IDEs, are software applications that provide comprehensive tools for writing, testing, and debugging code. They offer features such as code editors, build automation, debugging tools, and version control integration. Examples include Visual Studio, IntelliJ IDEA, and PyCharm, which cater to various programming languages and development workflows. Text editors are lightweight tools for editing code, offering features like syntax highlighting, code auto-completion, and customizable configurations. Popular text editors include Sublime Text, Atom, and Visual Studio Code, which provide a minimalistic yet powerful environment for writing code across different programming languages. Version control systems are software tools that track changes to source code files over time, enabling collaboration and version management. Git is the most widely used VCS, offering features like branching, merging, and distributed version control. Platforms like GitHub and GitLab provide hosting services for code repositories, facilitating collaboration among developers and teams. Environment setup is crucial for ensuring consistency and reproducibility in software development. This includes configuring compilers, interpreters, libraries, and other dependencies required for development. Platforms like Docker provide containerization solutions for creating consistent development environments across different systems, simplifying the setup process and improving portability. Choosing the right tools and environments is essential for maximizing productivity, collaboration, and code quality in programming projects. By leveraging abilities of IDEs, text editors, version control systems, and development environments, programmers can streamline their workflows and focus on what they do best, writing great code. Let's explore some essential best practices that contribute to the development of high-quality and maintainable code. Write clean and understandable code by using meaningful variable names, consistent formatting, and appropriate comments. Following established coding conventions and style guidelines specific to the programming language or project enhances code readability and facilitates collaboration among team members. Include comments in code to explain complex logic, algorithms, or non-obvious functionality. Additionally, write clear and concise documentation to describe the purpose, usage, and behavior of functions, modules, and classes. Proper documentation helps developers understand code more easily and accelerates the onboarding process for new team members. Test code thoroughly to identify and fix errors, ensuring that it behaves as intended under various conditions. Utilize testing frameworks and techniques to automate the testing process and maintain code quality over time. Additionally, use debugging tools and techniques such as breakpoints, logging, and stack traces to diagnose and resolve issues efficiently. Utilize version control systems such as Git to track changes, collaborate with team members, and manage project history effectively. Follow best practices for branching, merging, and committing code to maintain a stable and organized code base. Version control enables developers to revert to previous versions, experiment with new features, and coordinate work seamlessly within a team environment. Adhering to programming best practices promotes code maintainability, readability, and reliability, leading to more robust and efficient software development. By incorporating these practices into your workflow, you can ensure that your codebase remains scalable, resilient, and easy to maintain over time. Now, let's explore some real-world applications where programming plays a crucial role in driving innovation and solving complex challenges. Programming is essential for creating dynamic websites and web applications using technologies such as HTML, CSS, JavaScript, and server-side languages like Python, Ruby, and PHP. From simple personal blogs to sophisticated e-commerce platforms, programming powers the vast ecosystem of the World Wide Web. Programming is used to develop mobile applications for various platforms, including iOS, using Swift or Objective-C, and Android, using Java or Kotlin. Mobile apps have become an integral part of our daily lives, offering convenience, entertainment, and productivity on the go. Programming languages like Python and R are widely used for data analysis, machine learning, and statistical modeling to derive insights from large datasets. From predicting customer behavior to optimizing business processes, data science enables organizations to make informed decisions and drive growth. Programming is integral to the creation of video games, involving tasks such as game logic, graphics rendering, user interaction, and network communication. Whether it's casual mobile games or AAA titles for consoles and PCs, programming brings virtual worlds to life and engages players in immersive experiences. Programming enables the development of automated systems and robots capable of performing tasks in manufacturing, healthcare, transportation, and other industries. From assembly line robots to self-driving cars, programming empowers machines to augment human capabilities and improve efficiency. These are just a few examples of how programming is applied across various domains to create innovative solutions and drive technological advancements in today's world. As technology continues to evolve, the possibilities for applying programming skills to address new challenges and opportunities are virtually limitless. Let's explore how programming has become an integral part of our everyday lives, shaping interactions with technology and influencing various aspects of our daily routines. Programming powers smart devices such as smartphones, smartwatches, and smart home appliances, enabling functionalities like voice recognition, artificial intelligence, and internet connectivity. From setting reminders on your smartphone to adjusting the thermostat with your voice, programming enhances the capabilities of everyday devices, making them more intuitive and responsive to our needs. Programming algorithms are used by social media platforms to personalize user experiences, recommend content, and analyze user behavior for targeted advertising. These algorithms analyze vast amounts of data to curate news feeds, suggest friends, and prioritize content, shaping our online interactions and influencing the content we consume. E-commerce websites utilize programming algorithms to recommend products based on users' browsing history, purchase behavior, and preferences. These personalized recommendations enhance the shopping experience, helping users discover new products and find items that align with their interests and preferences. Virtual assistants like Siri, Alexa, and Google Assistant rely on programming to understand and respond to user queries, perform tasks, and integrate with various services and devices. Whether it's setting reminders, playing music, or controlling smart home devices, these digital assistants leverage programming to streamline daily tasks and provide personalized assistance. Programming has become deeply ingrained in daily activities, shaping interactions with technology and influencing decisions in areas such as entertainment, communication, and commerce. As technology continues to evolve, programming will play an increasingly important role in enhancing convenience, efficiency, and connectivity in our everyday lives. As we harness the power of programming to innovate and solve complex problems, we must also confront various challenges and ethical considerations that arise in the digital age. Programming introduces vulnerabilities that can be exploited by malicious actors for unauthorized access, data breaches, and cyber attacks. To address these concerns, developers must implement robust security measures such as encryption, authentication, and input validation to safeguard systems and protect sensitive information. Programming involves handling sensitive user data and raising concerns about privacy infringement, data misuse, and surveillance. Developers need to prioritize user privacy and comply with data protection regulations such as GDPR and CCPA. Upholding ethical data practices and ensuring transparent data handling procedures are crucial to building trust with users. Programming algorithms may reflect biases present in the data used for training, resulting in unfair or discriminatory outcomes, particularly in areas like AI and machine learning. Developers must address bias through data preprocessing, algorithmic fairness techniques, and ethical oversight to ensure equitable outcomes and promote inclusivity. Programming should prioritize accessibility to ensure that software and digital services are usable by individuals with disabilities. Compliance with accessibility standards such as WCAG and inclusive design practices can enhance usability and provide equal access to all users, fostering inclusivity and diversity in the digital landscape. Addressing these challenges and ethical considerations requires a proactive approach from programmers, emphasizing accountability, transparency, and responsible use of technology. By prioritizing security, privacy, fairness, and accessibility in programming practices, we can create a more inclusive, equitable, and ethical digital future for all. In closing, I'd like to leave you with a final word of appreciation and encouragement. Whether you're just starting on your programming journey or seeking to deepen your skills, remember that every step you take brings you closer to unlocking new possibilities and realizing your potential in the world of technology. As you continue your exploration of programming, I encourage you to stay curious, persistent, and open-minded. Embrace challenges as opportunities for growth, and never hesitate to seek support and guidance from the vibrant programming community around you. Thank you once again for your attention and participation. I wish you all the best on your journey ahead, and may your passion for programming continue to inspire and empower you in all your endeavors. Farewell, and happy coding.